We have a lot more to do today in section 6.4, which was our rational exponents, our rational exponent section. Remember just in general that if you have a number that's to an exponent written as a fraction, the numerator tells you the power and the denominator tells you the root. So we're going to keep practicing that today. And more simplifying and different types of simplifying. And of course, some more division. And I guess just kind of in general, more complicated simplifying. So we'll start off with example 3 here. And kind of like what I was doing in those last videos you watched, I'll have 2 problems in example 3a, and then I'll have 2 more examples in example 3b. So our first one here, let's do the square root of x cubed over the cube root of x squared. And right now, if I look at this, I think, well, I can't really think of this as one big radical because I have a square root and I have a cube root. There's not a whole lot of simplifying we can do here, but actually, if we instead think of this as a rational exponent, our square root of x to the third is really x to the 3/2 power. Again, remember your numerator is the power, denominator is the root, over, right here we'd have x to the 2/3 power. We can actually do something here because I have powers of x. In both cases, x is my base. So if I have the same base and a power over a power, we subtract those exponents. We really just have to figure out what is 3/2 minus 2/3. And I know we love fractions, so let's do this. We need a common denominator to make this work. In my denominator, I'm going to want to be 6. So 3/2 is 9/6. 2/3 would be 5/6. 4/6, which gives me my answer of 5/6. So the square root of x cubed over the cube root of x squared, which we did our rational exponents in the middle, we really end up with x to the 5/6 power. And just kind of in general, we don't like having a rational exponent in our final answer. We're better off writing this back in radical form. But denominator is our root, the 6th root of x to the 5th power is my final answer. So just kind of in general, here's some rules for simplifying. If you're kind of wondering, is it simplified all the way? Here are 3 things that we want to make sure are true. We don't want any radicals in the denominator. We don't want any rational exponents. And I'm just going to clarify in here that whole numbers are okay. Because whole numbers are rational numbers as well. We just don't want any exponents that are like 2/3 or 3/5. And then my last rule for is it simplified, we don't want any negative exponents. So whenever you're asked to simplify, we just want to make sure all 3 of these things are true. No radicals in the denominator, no rational exponents, no negative exponents. Okay, another example of simplifying, if I had the square root of 7 times the cube root of 7, we saw something like this in yesterday's videos, where right now I can't actually multiply these because I have a square root and a cube root. The index is different. But square root of 7 is 7 to the 1/2 power. Cube root of 7 is 7 to the 1/3 power. And exponent properties say we add these together. So again, fraction work, 1/2 plus 1/3. Get a common denominator of 6. I end up with 5/6 by the time I do my addition here. Okay. So I get 7 to the 5/6 power. Again, we don't want any rational exponents, so put this back in radical form. The 6th root of 7 to the 5th power. And we can figure out what 7 to the 5th power is, so we might as well. We get the 6th root of 16,807 is my final answer.